Welcome to the Twin Cities.net user group, February 2026 edition. Today, we're happy to welcome Sam Nasr, who's got a lot of letters behind him, MCSA, MVP, MCT. He is going to be talking to us about data cleansing using Databricks. But before we get into that, know that Sam is a senior software engineer with NIS Technologies, consults and teaches clients about the latest .NET technologies, and he has been a leader of the Cleveland C# group since 2003, 23 wonderful years. And he's a pretty all-around great guy. Sam, take it away.
Thank you, Jason. Glad to be with the group again. It's always a pleasure presenting to this group. Little bit more about me. You can find me on X at Sam Nasr. I've been a software developer since the ripe old year of 1995. I'm a senior software engineer and trainer for NIS Technologies, and like Jason mentioned, certified with a few certifications in Microsoft. I also run the Cleveland C# user group, as well as the Azure Cleveland user group. In addition, I'm a technical author for both Visual Studio Magazine and LinkedIn Learning, and I'm an 8-time Microsoft MVP. A little shameless plug, if I may, for the Cleveland user groups that I host. We meet every month. The meetings are free of charge and open to the public, and you can find all the meeting information posted at meetup.com at the perspective links for Azure Cleveland and the Cleveland C# user group. So let's dive into tonight's presentation. But first, I want to set the expectations so that way we're all on the same page. We're going to be talking about data cleansing techniques, why it's important, what we need to do, and then we're going to talk about a light overview of Databricks. Please keep in mind this is not a full tutorial on Databricks, but rather more of an overview, enough to get you to a level where you're dangerous with Databricks and you can actually execute some of the things that we're going to talk about. And then we're going to look at some of the tools and techniques that are used for data cleansing within Databricks. So let's dive into it. And why do we need to have data cleansing? Well, first and foremost, you want to avoid the old adage, garbage in, garbage out, right? This is something that's been around as long as computers have been around. We always want to scrub the input, make sure that we're going to be training the model on good, accurate data. We want to avoid skewed or biased results. And we want to prevent overfitting. Overfitting is when you provide the model with limited data set and it ends up memorizing the data as opposed to looking at the overall algorithm and the trends in the data. And so then it's basically the equivalent of, instead of training you on how to take a test in algebra, for example, I am giving you the answers along with the questions. So you're really not learning, you're more of memorizing. So we want to avoid that as well. And then a big thing that we're going to talk about is how we're going to handle missing values in data. And more importantly, what are the proper techniques for handling it and some of the things to consider as we maneuver through some of these methods. So basically, data cleansing is going to be isolated into 3 separate silos. We're going to look at first the data collection aspect of it and how we collect data. We're going to look at the structure and ensure that it fits with the right data types and the schema, as well as the business logic within our application. And lastly, we're going to look at the values, make sure that we have no outliers, make sure that we have the right samples, and like I said before, we're going to populate the missing values. So first and foremost, collecting the data. A lot of times with a machine learning project or an AI project, executive management will say, well, we already have the data, take it, train the model, and let's get going with it. However, the first step in data cleansing should be asking, were all the options equally visible for the user when they selected a specific option? And let me give you an example. So here you see obviously it's a fictitious website for selecting airline seats, but you see there's 3 options there, right? If I want to upgrade to first class, it's an additional $250, business class is $100, or the Econo Plus is an additional $25. right? So if you were presented with these options with this screen as you see here, typically what are most users going to select? And feel free to come off of mute or enter your answers in chat. All right, so I assume what people are wanting to say is that you're going to select the $25 option.
Oh no, I was trying to come off mute. If it's my wife, she's definitely selecting the $250 option. So that's guaranteed. So she only flies first class. So
Hats off to Mrs. Erdahl. But what would Mr. Erdahl select?
the middle one, of course. I mean,
The
so
middle.
you obviously
Okay.
don't want to go super cheap, but 250 looks like a ripoff. So I gotta get the middle one. That looks great.
Okay, so understandable. However, looking at this, it seems like these are the only three options that are available to you, correct? However, what you don't realize is there's an option down here, and as you see, as I highlight the link at the
Oh,
bottom,
oh,
there we come on, there we go. As I highlight that link at the bottom, we can continue with standard seating at no extra charge. So a lot of times the airlines will do this. Granted, this is a bit of an exaggerated example, but as you see, I hid the link, have it down below. It's not as visible as the other three options. So the point that I'm trying to make is um, we have to look at the data and how was the data collected? Were all the options equally visible? So we know that the user selected something that is actually fitting for them, or were they kind of forced to pick a specific option more than the other? Getting back into the collecting the data correctly, the other option or the other thing that we need to look at is we want to ensure that users are not influenced by other factors. What I mean by that is, I was involved in a volunteer group, and we essentially said that we need to break out into three subgroups. We need people to develop a website, people that will do outreach, and people that will do action-based services within the community. If you're interested in any of these three groups, put your name in the hat, and there's going to be an Amazon card drawing. So naturally, when people heard Amazon gift card, they put their name in all three hats. We went to call them, and nobody really wanted to volunteer for any of those three. So they were influenced by the fact that there's an Amazon gift card, and so it skewed the end result, and it forced them to put their name in all three hats. So again, that's another thing that we need to look at when we're evaluating how the data was collected. Last but certainly not least, we want to look at how was the data provided? Was it manually entered or was it automated? And it's hard to believe that in the year 2026 that there's some data that is actually manually entered, but it's true. It happens. And a lot of times it's entered into a spreadsheet. And obviously, we all know from experience using spreadsheets, it's essentially free form entry. So anybody can put in anything, right? So as opposed to automated data that was collected through API calls and then populated into a relational database, we know that it follows the constraints much closer as opposed to free entry data. Once we have identified how the data was collected and we verified that it was done correctly, now the next thing that we need to do is talk to the subject matter expert and utilize them. One of the biggest mistakes is that developers will start building a ML model before understanding what the business is all about. So for example, let's say that we want to build a machine learning model for predicting housing values. What are some of the factors that predict the price of a home? Obviously, the square footage, the number of bedrooms, number of bathrooms, but then the biggest one of them all is the zip code, where it's located, right? Location, location, location. We obviously buying homes is something that we've all have done or will be doing, so we're somewhat familiar with it. But that's not to say that we're all familiar with how a specific business functions and all the nuances within that business. So it's always important to reach out to a subject matter expert within the organization and get their input on what fields the model should be trained on. Also, we need to identify a specific objective statement. What is it that we're trying to solve? A friend of mine, we met recently, and he was telling me he had his management team come up to him and they said, uh, use whatever you need to in this AI thing to make us money. That's not really a clear objective statement, right? Certainly you have the data where you can build models around it, but what is the objective that you're trying to obtain as opposed to just making money, sort of quote unquote? And the value of the SME is that they can provide or and identify key input values. And again, that's for helping to train the model to be able to provide the correct results. In addition, some data, it may require the historical prices, or in some data may not. For example, if I am doing LDL in comparison to body weight, it really doesn't matter when that measurement was taken. It's kind of a proportional trend. As opposed to home prices, the price of a home back in the 80s is far different than the price of a home today. So do I capture the time and date of this that along with those features or not? That is something the SME would be able to answer. One of the things that we always hear about in machine learning is that more records equals a more accurate model, which is somewhat true. The more correct statement is more records with context equals a more accurate model. What I mean by context is, again, going back to our home prices, aside from the obvious, the number of bedrooms, bathrooms, and the zip code, we also want to look at other factors, meaning, does it have any insect damage? Does it have any fire damage? Um, any other aspect we need to identify that may uh, help provide better context for why the price is high or why the price is low. Does it have a swimming pool? Are there tennis courts? All these are things that can that provide context as far as to help identify why the price is at either extreme. I wanted to pause here for a second. Everyone with me? Any questions so far?
I'm with you.
None so far.
Excellent.
Looks good.
All right, very good. Next, we want to look at the data types and the schema that we're going to be using for our data. Pardon me, I had a comment in chat. But what we want to look at more specifically is, does the data adhere to the data types? And specifically, if we're collecting data in a manual form or getting it from a trading partner, where sometimes when it comes across the wire, it's in XML or JSON, so it's just simple text. And we need to take that and be able to process it. So the first thing that we need to look at is, does the data adhere to the actual data types? Is a date an actual date? Or are there fields that are missing within that date? Is age an number, or is it coming as text? So these are things that we need to make sure that the data adheres to the data types. And we want to check for data integrity. So as far as a relationship within the data, where you have one to many, we need to ensure that the data adheres to that relationship as well. And we want to look at required fields versus optional fields. So all the input fields are going to be used for training the model. They have to be required, otherwise the results may not be meaningful. And then when it comes to the actual schema, essentially what we want to do is take whatever data we've been given, whether it's in JSON format or flat text or a spreadsheet, we want to import that into a relational database. The reason being, once we import it into a relational database, it helps to validate it with the schema, the data types, the relationship, numeric ranges, as you see identified there. So it helps to ensure that once the data is imported, that in fact it fits the schema, and then we're good to go. The other thing that we want to look at is to ensure that the business logic. So a lot of times we have the application doing the upfront checks to make sure that as the data is being inserted, that everything matches. For example, if we're looking at medical procedures, a procedure that applies to a male may not apply to a female or vice versa. right? So if we're getting that data imported from a trading partner or a customer in JSON format, we want to make sure that it fits the logic of what we have in our application. Since, again, we're receiving data as opposed to our application inputting that data into our database. Other things that may not jive, doing AC maintenance on a motorcycle. Obviously, no such thing, right? Or snow removal in summer months. Obviously, that wouldn't apply. We also want to scan for distinct values to make sure that we have a good breadth of all the possible values that are available. Now, getting into the data, we want to look at outliers. So outliers are essentially categorized into two categories. There's noise, and by noise, I mean data that is really not that valuable. So if we look at home prices, a price of a home typically would be like 335.9, right? You're not going to go down to the nearest dollar and the cent on the sale price of a home. So there's no need to mention that. It's just additional noise. We can simply discard that. Another thing that we want to remove is we want to look at outliers. So if we know that the sale price of homes within a specific area is between 300 to 500K, but we have a property worth 12 million. Why is that? If it's only one property, we have to identify why that is, and then preferably remove it so that it doesn't skew the results of the data. The training of the model rather. And then the other thing we want to look at are the samples. We want to remove redundant features from the data samples. So if we have data on a specific home, we may have the square footage of the land, but then if we have another field that provides acreage, there's no need for that. It's better to discard that. You only want one version of the truth. So for example, let's say the square footage or of the land, and again, this is just off the top, is 10,000 square feet, for example. But then the acreage is set to 0.1. So which one do I go with? Now I have two versions of the truth. I need to work with only one. So there's no need for redundant features. We can just simply drop one of them. I also want to remove irrelevant features from my training model. And this is something that my subject matter expert would assist in. Some irrelevant features, street name, right? Unless the street is really some bizarre name, the location and the zip code is what dictates the price of the home as opposed to the name of the street. And we want to normalize and scale all the features. And by features, I mean the columns that we're training the model on. So for example, for prices, are we listing the number to the nearest thousand or are we listing it to the nearest dollar? So do we specify 100 representing 100K or do we specify 100,000 with the 5 zeros? We want to make sure that we're consistent all across the board. You can't say 100 for one and 100,000 for the other and expect them to mean the same thing. And the same thing applies also for the labels. So should have mentioned this earlier, but in machine learning lingo, a feature is what you're training your model on, what it's learning, i.e. the number of bedrooms, bathrooms, etc. These are all features. The label is the outcome, the final price of the home. So we're going to be training on that, and we're doing supervised learning where we're giving it features as well as labels. We also want to make sure that the labels are consistent, just like our features are consistent. Now we get to the fun part. What if we have missing data? How do we resolve that? Well, the lowest hanging fruit for resolving missing data is simply to try to reverse engineer it. That's possible in some cases, but not always. For example, if I have a first name and a last name, first name is Sam, but the last name is missing. And this employee I know works in the engineering department. So if I'm familiar with a staff in the engineering department, I know there's only one Sam, so therefore the last name has to be Nasr, right? Kind of obvious. Again, This is not something that's going to fit all scenarios, but it's something that worth exploring. The other option for replacing missing data is with mice, and that is an acronym, and we'll talk about that in just a second. But that is a computational algorithm that essentially goes through the data and using linear algebra, it attempts to guess the missing values, and it actually works very well, as you'll see in the demo. We can also use custom substitution values. For example, if I have a value that's missing, I can just simply replace it with 99. And that way it will stand out as the missing value when I am training my model. I can also use the law of averages, and I have 3 different types of averages to choose from, and there are pros and cons to any of those methods. So I can use the mean, the median, or the mode, and more about that in an upcoming slide. And of course, one of the easier options is just simply remove the entire row, right? And this depends more on how much data I have versus how much bad data I have. So if I have, let's say, 10,000 records and only 2 have missing values, it may not be worth it to actually go through the struggle of resolving what those values are, but rather I can just omit those 2 records and be done with it. Another option is using the principal component analysis, and that comes in 2 flavors. There's the deterministic or the probabilistic, which again goes through probability to estimate what that value is. And again, this is some linear algebra that goes through and chugs through and estimates that missing value. I will put you all at ease. We're not going to be doing any linear algebra tonight, but rather we're going to be making calls within the Python code to actually take care of that for us. So let me pause here and ask any questions so far.
Nope, not yet.
Okay, very good. And I don't see any in chat. And again, I should have said this earlier, but feel free to jump in at any point with questions or comments. You don't necessarily need to wait until I ask for it. Let's make it as informal as possible. So, having said that, let's dive into Databricks. So what is Databricks? It is a cloud-based data platform that's built on Apache Spark. And the nice thing about it is it provides what I call one-stop shopping for everything. I have my data, I'm able to open up my notebooks and be able to run Python code and be able to slice and dice the data as I need to. We have a question in chat. What do you consider in choosing the method to replace missing data? Very good. If I could ask you to hold off on that question, as we step through the demos, you'll see some of the pros and the cons as we step through that. But thank you for your question. So back to our presentation with Databricks, like I said, is a one-stop shopping for your data as well as manipulating it. So it utilizes the Lakehouse architecture, which essentially can import various tables, structured and unstructured data, all in one area. It's useful for processing big data, building the ML models, and using the AI for insights. Another advantage is that it allows you to use the language of choice, depending on your preference. In my case, it was Python, and it utilizes the Delta Lake as the database engine, and everything is done in the cloud. So keep in mind, it is not a traditional RDBMS, it's a lakehouse. However, I can use relational data within my lakehouse. So with Databricks, let's jump into So this is my Azure portal, and I have a resource group. Basically, what I did was I have a resource group dedicated for Databricks. And then within that resource group, and here it's RG-NIST. And within it, I created the resource for Databricks. and I added it just as any other resource would be added to a resource group. Once that's added, now I can click the launch workspace, and then it takes me into Databricks, where it automatically logs me in using my Azure credentials. So with Databricks, it comes into multiple flavors. You have the Community Edition, which I'm using here. You also have Standard, Professional, and Enterprise. Obviously, different tiers, different pricing, different features available. Now that that's open, I can go into my workspace, and here you see that I have several items that are open, or excuse me, that have been stored. So I have notebooks that are available. I have CSV files that I uploaded. In addition, if we go over into the catalog, you see that I have several databases created. And there's my catalog. It already comes standard. No, I'm sorry. These were samples that I had imported previously. And getting back into my workspace, now I can open up a notebook and let's go through the mice example. So you'll see that this is a notebook that is going to be utilizing the Python language. And basically to create a notebook, click on the ellipses, create, and now I can select notebook. And it opens up a new notebook for me. And then I can select the language of choice, whether it's SQL, Scala, R, Python, or what have you. Okay. So let's talk a little bit more about mice before we dive into the demo. So with mice, it stands for multiple imputation by chained equations. Rolls off the tongue very easily, right? And kind of self-explanatory. Not so much. What that means is that it's an iterative method that models each variable with the missing values, and it produces a function out of it. And then it's a function for other variables, meaning it will look at that missing value and see what could be a good fit for that, that it would fit in with the trend overall of the data that I provided using the other columns as well. And then it goes through multiple iterations, and it goes through it repeatedly by guessing the missing value using regression models. So this is more math than I care to explain or care to learn. Once I finished linear algebra at Cleveland State, I was done with it. I didn't want to touch it any further. But thanks to Python, everything is available to me through a Python call where I can now access these features. So this is ideal for complex data sets that have non-random missingness or interrelated variables, meaning that you can see the values that are related to each other, but some values may be missing. So for our data set, we have age, income, and education. And within the income column, we have some missing values intentionally. And what we're going to do is that we're going to run through the algorithm. Mice is going to fill it in with the mean value, the mean average rather. And then the model is going to model the income using age and education. It's going to look at the other related fields. And then it's going to impute that missing income value based on the model, and then run through it multiple times and iterate through it for several iterations until it comes up with a final value, and then it will present that. Okay, so the best way to explain things, like I always say, is through a demo. So getting back into our Databricks, we have the mice example up. And as you see here, my language of choice is Python. I am importing the scikit-learn. And then for good measure, I always restart the Python kernel. I then do my import for sklearn. I import the libraries for NumPy and Pandas. And then sklearn here is where I'm using the iterative imputer that's going to be used for the mice call. And then I'm giving it a sample data set. And you'll notice that it contains three columns: age, income, and education. And specifically within income, I have two missing values, or NaN for short. What it's going to do, it's going to print out the original data value with the missing fields. Then I'm going to call the iterative imputer. I'm going to tell it to run through a maximum of 10 iterations. It will then train on the data and impute the value. And then it's going to output the value where then it will be presented in the final data set where it's going to be printed out. Okay, so I'll go ahead and click the run, and it's going to run the cell. So in this notebook, it's basically like any other notebook. I have cells. I can execute each cell individually. I can select the language of choice, and then I see the output execution from each cell. This one will take just a minute. It's going to clear out the previous output. Should have brought some mice music while we were running this algorithm, but as you see, it went through fairly quickly. So here's the original data set with the missing values. And let's assume that the trend that income is based on age as well as education. So for a 25-year-old who has a 12-year education, he has an average income of 50,000. A 35-year-old with 2 years of community college makes 70,000. And likewise, someone with a graduate degree makes 90,000 at the age of 45. So we see the trend here: 50, 70, 90. So what could the possible missing values be? So after it runs through the 10 iterations that I had specified, it plugs in the mean averages, runs through it multiple times to make sure that that fits. And there we see a perfect fit for the data. So we have the 30-year-old. It's estimated that he would make 60,000, or she. And likewise for the 40-year-old, he would make 80,000 with 18 years of education. So it fits within the trend that I had of the data set that I had provided. And the beauty of it is I didn't have to do any linear algebra. It was basically just the calls in my Python cell and call the iterative imputer. Okay. Any questions or comments on that?
I have a question, Sam.
Please.
In that data frame, did the whatever AI, did it figure out that age and education have a relationship to income on its own?
So basically, short answer is yes. This is the data set that was provided, and this is what I had trained it on here in this statement where I said fit underscore transform. So it's using the entire data set, which contains these three columns.
Okay. All right.
Other questions or comments? But thank you for your question, Will.
Yeah, did you see the question from Chuba at 609? What do you consider in choosing the method? If you did and answered it, sorry, I missed it, but
Okay.
that was a question that
No, I
came in.
didn't quite answer it because there's other methods that we're going to go through.
Cool.
There are pros and cons to consider. Like when we talk about the missing value specifically with the mean, mode, and median, we'll talk about the pros and cons with those. So I didn't forget about that question, but we'll definitely touch on it later. Anybody else? Okay. So again, feel free to jump in at any point in time. So mice is one way of filling in the missing values. Another method is the principal component analysis. And this essentially does more than filling in the missing values, but rather it combines a complex data set and it reduces it into something a little more simplistic. So let's take, for example, where we have a data set about cars. So there are many features to consider about a car, horsepower, engine size, and 6 other features as you see here. I want to be able to make that data set a little bit more portable, if you will. I want to be able to have a better handle on it. I don't want to work with 8 different columns. So PCA allows me the ability to do that. And what it does is it simplifies the complex data set by reducing the number of columns within that data or the features. And it transforms the original features into a new set of features called principal components. And again, this is leveraging linear algebra. And it focuses on preserving the variance or the spread in the data. So as we know, the engine size may not necessarily be proportional to the data or to the horsepower rather, because it could have a turbocharger or nitrous or some other power enhancer. So it looks at the spread of the data and then it preserves the variances. And it uses a deterministic algorithm. By deterministic means that it will be the same answer each and every time given the same set of features going in. So if I say x plus y, it will always equal to z. So the advantage of using PCA is that I now have compressed data. I have less noise to deal with. I remove the uncorrelated features and I have a clearer structure. And then this will also help me develop a better performance for my machine learning model. So this one example is a little bit cryptic, but you'll get the point of it once we pull it up Databricks. So we'll go over into the PCA example, which is in another notebook. And again, very similar setup where I'm using Python. I'm bringing in the libraries that I need to, and then I am setting up random features to be used for my columns. So I have raw feature 1, 2, 3, 4, and 5 different columns that I'm going to be generating with random numbers. I'm going to fill those in. And then what I'm going to do is I'm going to take that data and I'm going to call the fit underscore transform, which will essentially utilize the PCA that I instantiated here. And it will train that model. And then the output columns will be reduced down to 2. So I will go from 5 columns down to 2. So let's go ahead and run through this. And we'll hit run.
While it's running, I just wanted to ask, can you repeat again why would it be reduced down to 2? I missed that. I must have missed that.
Why are we reducing it down to 2?
Yes.
So looking at the previous slide that we talked about, so the advantage of reducing it, I have a compressed data set. I'm no longer dealing with a large data set. And now that compressed data set is representative of all my features that I provided it. So instead of working with 8 columns, I'm now working with 2, or in this case, instead of working with 5 columns, I'm just working with 2. So these are the advantages that you see here on this slide of being able to use that and compress it down into a smaller data set.
Okay, no worries. Thank you. I had to go in and I came back, so I must have missed that. But thanks.
No problem. All right, so getting back into our notebook. So as we see, it provided the raw features. There are some missing values that are built in, and I have it intentionally. As you see here in the comment, it introduces a missing value in every 10th row, and this is intentional. So there's one null value, another, and every 10th row, there's a null value. And it produced 100 rows by 5 columns. This 1.2 is just simply an indication that this is a double type. So now we went from 5 columns with some missing values. And if we scroll down, now we see the filled feature, which now has the populated values for every 10th column. So it filled in the missing values using that algorithm. And then if I scroll down even further, now it reduced it down to only 2 columns, which I can then use for importing into or training my model on just those 2 columns. So it would make for a faster training of the model and more accurate by combining these fields in a smaller data set, as well as filling in the missing values. Okay. Any questions on that?
Um, Probably. I was just wondering about outlier values. How do they get treated in these cases when it comes to combining columns?
So that would all be factored in. However, I would suggest that you handle the outliers before starting this type of process, just to avoid having things propagate down. Meaning, I don't want an outlier value if I'm not going to be depending on it, right? I want my model to focus on the specific data, the majority of the data, uh, as opposed to throwing in an outlier that could skew things. So I would handle that before getting to this stage.
Cool. Makes sense.
And speaking of outliers, so one way of doing it is that I found very valuable is just using a scatter plot. And that is a quick visual representation of looking at your data and seeing where the points are and if there's any outliers. So in this case, I plotted out body fat versus age. And as you see, everything lies within the specific range that I have here. I don't have anything that is outlying on a far extreme. So it's a great visual representation. This was done again through some Python code using the matplotlib, but a very quick and dirty way of doing it. Well, I shouldn't say dirty, but it is definitely very quick. Scan the data for maxes and min values, and you can easily see where the outliers are at or if things are within range. So there's multiple ways of doing it. I just prefer the visual method like this.
Nice. Thank you.
You're very welcome. All right, so after that demo, now we can look at custom substitution values. So if we have missing data, we can specify a specific value, such as -999, or just simply specify unknown. And so this will create a separate category. We definitely don't want to use an existing category or an existing value so that it doesn't conflict or skew the output of the model. And in some cases, missingness has meaning. So for example, we've all worked with nullable data types. And if you have a nullable Boolean, that could be either true or false, or if it's nullable, then that means the user didn't answer anything at all, right? So in some cases, if missingness has meaning, we want to preserve that, such as where they didn't answer a question, right? So we want to leave that untouched. We can also utilize decision trees, random forest, and gradient boosting. But then again, this is like more on the higher end of more advanced machine learning for handling missing values. But we can also utilize the standard imputation, meaning the averages that we talked about, the mean, median, and mode. And we'll talk more in detail about that in just a second. But being able to substitute a missing value using a custom value, it allows us to preserve the data where we no longer have to discard the records that are in question. We can work with entire data sets. And by providing a custom value, it avoids having to make assumptions about the distribution, meaning we don't have to guess what value we're going to give it. It's going to be with a value or a category all its own. Now, diving more into the averages. So we have three to choose from: the mean, median, and mode. Which one is a good fit for what we're going to use for a missing value? Given the data set that we have here, we have five numbers: 2, 3, 3, 4, and 100. Obviously, 3 is repeated twice. When we talk about a mean, the mean essentially adds up all the numbers together and then divides it by the number of elements in that array. So in this case, we add everything up, and then when divided by 5, we have 22.4. The median essentially picks the middle value of that entire data set. So in this case, since we have 5 values, the value in the middle is 3. And then mode is the one that happens most frequently, which is 3 in this case. So the chart down below best summarizes everything of the best use scenario. So we'd want to use mean when the data is symmetrical and continuous. Excuse me. We'd want to use the median if the data is skewed or has outliers. And as we see, most of the data set values are on the lower end of the spectrum, with exception of that last value being 100, that's way off. So in this case, as we look at the numbers, if we use mean, that single outlier value skewed the data significantly in comparison to the median and the mode. 22.4 is significantly higher than the number 3. And then mode is if you have an occurring value and the frequency thereof. If that happens frequently, then the mode would be the better way to go to be able to select the more frequent value that occurs within the data set. So when to replace it with mean? With mean, it fills in the missing numerical value with the feature's averages. It's quick and widely used, but sensitive to outliers. So as we had seen in the previous example, that single point of 100 skewed our end result significantly. It can reduce the variability if the missingness isn't random. Can replace with median, where it substitutes the missing values with the middle value, and that is more robust to outliers. And as we had seen, we had the value of 100, but because of the median that chose the middle value, it was less susceptible to that to the outliers, either on either extreme for that matter. So this is excellent when we have skewed or non-normally distributed data. And then mode is ideal for categorical data for things like color or job title. Things fall into categories. Replacing it with mode, where things are happening frequently, that is the better option to choose. So it imputes or selects the most frequent category within the set of features. And it can skew class distribution if one category is already dominant. So that's the downside of it, is if we have one category that's dominant, let's say it repeats more than the others, even by one, then mode would be that value. So that's the downside of that. Now, let me pause here for a second and go back to, is it Chuba? Where you asked, what do you consider in choosing the method to replace the missing data? Does that answer your question?
That was a question from before, Sam. I think you had answered it.
Okay, very good. Yeah, I just wanted to confirm with him and got the answer. Very good. All right. So moving right along, we talked about removing the entire row. When is that useful? It's effective when the number of affected rows is small. I have a large data set. The number of rows that I am considering removing is relatively small. Now, I say relatively, that is something that you'll have to decide. Is 1 out of 100 small? Is 1 out of 50 small? That is up for you to decide at the time when you're deciding to remove that row or not. The risk is it could lead to loss of valuable data or some bias. And I always caution, track the number of rows removed. Granted, you're going to be removing it and discarding it, so it's not going to affect the model. However, after the model is trained, you always want to document the data that it was trained on, as well as any data that was omitted during the data cleansing process. So you want to track the number of rows removed versus the total number of rows that were actually provided to the model for input. Another thing to consider is removing the entire column. This would discard the entire feature. If the missing data dominates, meaning that we have a lot of missing data in that column, and that column is not a requirement or something that is not a heavily relied on feature. And it kind of sums up what I was saying. It's appropriate only when the column adds little information or it can't be recovered meaningfully, meaning I can't put in a value meaningfully. And obviously, removing one column, if it's not adding a lot of value, not a big deal. However, removing multiple columns may weaken the model performance because now I have less features that I'm training it on. So take the example of the training a model on housing price trends. If I remove bedrooms, bathrooms, and other things and just leave it down to zip code, then obviously it's going to weaken the model performance as far as predicting the price of a home. Some outliers. We talked about this earlier, but to dive into it a little bit more, you want to look at why that outlier value, why it's there. There may be something that you overlooked. For example, if I have low value homes in a zip code that has high value homes, well, what's causing it to be low value? Is there fire damage? Should I be having another column to indicate whether that home is fire damaged or not? Or should I remove it altogether? Again, depends on the data that I have and how many records I have with outliers. Significant discounts. So in some cases, and specifically within housing, people can transfer the home from one person to the other, sell it for the price of $1. Obviously, you do that with relatives or, well, more than likely with relatives, unless it's some kind of an awkward deal. But if you do that, then and you're capturing that, then again, you need to know why the value is so low. And data visualization, like we said earlier, it's a great way of looking at the data and seeing that everything is contained within a specific quadrant, or just simply scan for the mins and maxes. Also, removing duplicate records, and we'll see that in another demo where I can utilize Python code to actually go through and scrub the data and remove any duplicate records as well as any null values. So let's take a look at that example. And where did it go? PySpark function example. There we go. So this is a conglomerate of basically all the Python functions that I have for scrubbing my data. And what I did is I have this sample data. And if we go over into my catalog, so this is my sample data. Let me open up the query. So here I have some employee data where I have some missing values, some duplicate records, and I'm going to utilize my functions that will go through and be able to look for certain things and then remove them. So first of all, I'm going to remove anything with a null. I'm going to drop it altogether, and I'll just use a function for drop NA for removing nulls. I'm going to handle missing values by putting in the median age. I'm going to remove duplicates based on name and social security number. And I'm going to remove any rows that have ages less than 18. We talked earlier about having the data being consistent. So in this case, I want my name to be completely lowercase and remove any additional spaces. And then I'm going to do a conversion to make sure that the data fits within the specific schema. And in this case, I'm going to look at these fields. I'm going to make sure that income is casted as a float, birth date is casted as a date, and then the ID field is cast as an integer. So I'm doing multiple things here as I'm going through and making sure that it fits within these criteria. Same thing with the full name. I'm going to utilize regular expressions to be able to remove or to ensure that it fits within the regular alphabet characters as opposed to having any special characters. Question: can data consistency be regulated externally? All depends on who your external resource is. I assume you're talking about getting data from a trading partner or a customer. Is that right, Malar? Yes. Okay. If that's the case, it all depends on what they are willing to commit to. Um, in my opinion, regardless of what they're willing to commit to, always scrub the data because in the end, you're responsible for what is being produced. And going along those lines, any data that I receive from an external source, whether that source is another department within my organization, an external customer, or a trading partner, any data that you're given, I store that off completely unadulterated, unmodified. I make a copy of it and then I start to modify it. The reason being, you'll eventually get the question, well, our data was sent to you correctly, and then you'll be like, no, there was actually some corrupted records. How do you prove it? You go back to the original copy that you have that you received before you modified anything. So, short answer, can consistency be regulated? All depends on the agreement that you have. However, regardless of what agreement you have, I would still go through the scrubbing process and make sure that it fits before you train the model on it. How's that for a short answer? All right, very good. Okay, so as you see, all these functions were basically built within the Python libraries within PySpark. And all I'm doing is I'm querying the data and then running through all these various functions. So we'll go ahead and run through the data, or the functions rather. And then it should output the data that's going to be cleansed and all the null records removed. And everything fits in within the schema as far as the data types that were specified. And as we see here, I don't have any missing values. Looking quickly at the age, I don't see anyone under 18. Now here's a question for you. I have birth date and I have age. What's wrong with that picture? A little trivia question for the evening.
Isn't that redundant data?
Exactly, right? There's no need to have both, because if I have age, that column will eventually become stale, right? As every year goes by, I need to update that field. It's best to record birth date and work off of that and then omit age altogether. Good one, Jason. You win tonight's prize.
Woohoo!
All right. Any questions? Okay. So eventually, what I'm trying to drive at is we looked at the basic building blocks of what it is that we need to do in our data cleansing. But essentially, you're not going to be doing this manually for every data set that you receive on an ongoing basis before you submit it to the model to be trained. What you're going to be doing essentially is creating a data pipeline, and this can be done within Databricks. But like I said, this is a topic that could be far greater than the hour that we have to spend tonight here. But this is something that is available in the Databricks, and I can create a pipeline where essentially the raw data comes in. I can then cleanse it. I can remove duplicates, handle the missing values, ensure that it falls within the business rules and the constraints. And once it's validated, then I can report on it to show number of records received, number of records removed, the data that was used uh, was essentially being cleaned, and then that could be submitted into the model for training. So what I'm getting at is we spent the last 45 minutes or so talking about these individual building blocks and what actually transpires that I have to do to cleanse my data. But in the end, this is the result that I'm driving towards, is to create a pipeline that will automate all these things for me within Databricks. And with that, that essentially wraps it up for me for this evening. Wanted to pause here for a second and see if there's any last questions or comments. And if not, then I would ask you all to come off of mute, and I want you to tell me, what is it that you've learned here tonight? Um, I'm going to skip the slide about images, but I want to hear from you. What is it that you've learned here tonight? Hopefully this was useful to you, but if someone asks you, what did you spend the last hour learning? What is your takeaway from this? And again, we can enter it into chat, or better yet, come off of mute. Are my notebooks on GitHub? Not yet, but they will be. And if I'm not diligent in doing so, I'll share my email address and you can reach out to me.
I guess I'll start first. Thank you, Sam. That was really great.
Thank you.
I definitely felt like it's not as intimidating as it, I guess, it seemed. And
Mhm.
so when you're talking about like cleansing the data and using it and combining it to make it less noisy, I immediately thought about situations, you know, with previous clients or my current work situation where there's a heap of like data that can be cleaned in a way, in a much safer, simpler way as well. So this was kind of like a almost like an encouragement as well as an eye opener as well into how
Excellent.
to use Databricks. So
Glad to
yeah,
hear
thank
that.
you,
And thank you for sharing that.
thank you.
Um, but more specifically, a question for everyone. Give me some technical aspects that you learned here tonight. Some do's, some don'ts, some things to watch out for. Would love to hear what are some of your takeaways.
I think that part of the thing that you mentioned was the different methods of analyzing for missing data and trying to come up with a decent way to do that. Um, I guess in previous things where I've been involved with things like that, a lot of times there was more of an upfront consideration for that, where if somebody, if you needed to get some data versus no data at all, you would let them enter blank data, and this helps figure out a way to perhaps fill in some data where those pieces are missing.
Yeah, now keep in mind that it'll work for it will fill it in, but it's dependent on the other values as well, and it looks at the overall trend. Um, so
Yep.
yes, and what is that technique called? Anyone remember? I'll give you a hint.
Is it imputation? No.
Close.
MICE.
Mice, right.
Nice.
And then there's the other one, the principal component analysis, that does the same thing as far as filling in the missing values. in addition to shrinking the data set down to 2 columns instead of 5. All right, very good. So I hope this was a nice primer for you as far as data cleansing. If you're ready and you want this as a class, I, as a trainer, am available to provide this through NIS Technologies. You can find all my on Linktree/Sam Nass. More specifically, my technologies.com. And I always encourage folks that just because the presentation's over doesn't mean dialogue stops here. You have my email, you have access to all my socials on Linktree, and you have my LinkedIn link, so to speak. So let's connect one way or the other. I'm more than happy to answer any questions, help you get a proof of concept off the ground, maybe even have a lunch and learn with your team. I'm happy to help any way I can. So with that, thank you all for attending. And whoa, sorry. Let me put that up one more time.
2 items for you, Sam. Do you have a YouTube channel? I know when
I
I've searched
do.
for your videos on YouTube, I found some really interesting stuff. I just didn't know whether you had a dedicated YouTube channel.
I do.
Okay, good.
So yes, and that is youtube.com/@SamNasserMVP. That is available on my link through my link tree. And there
Great.
I host the recordings for any user groups that either I host, any presentations I give, or other user groups as well.
Awesome.
So thank you for
And
having me.
then absolutely. And just so we can grab it for the recording as well, can you tell us a little bit about the Memphis event that you brought up
I'm glad
before
you brought
we
that up.
fired up the recording? Would love for our audience watching later to get that as well.
Absolutely. So coming up on Monday, March 16th is the Memphis Agent Camp, and that is going to be essentially an all-day session of various AI topics. It's going to be held remotely. Douglas Starnes is very active in the tech community based out of Memphis, Tennessee, and I will be speaking there on observability and AI Foundry specifically. And again, you can't beat for the price, right? Lots of AI related topics free of charge online, and everyone's welcome. So the link for that, I already put it into chat, but I would be happy to post it one more time.
And for those people watching this later on YouTube, we'll go ahead and put that down in the description as well.
Sounds great.
Outstanding. Okay, cool. Anything else? Or should we just give Sam a big round of applause?
Only if you think I
All
deserve
right.
it.
All right. Round of applause. Yay.
Thank you, thank you, thank you. Appreciate it.
Oh, look at all those. That's coming up great. All right. We are going to pause the recording so we can get into some serious conversation. All
All
right.
right.
Great. Thanks again, Sam. Much appreciated as